So this is the first question on your worksheet, and so for those of you who would like to have a little bit more of an idea of what it is that you need to do, I thought we would go over this together. These problems are pretty simple and straightforward. Like any good problem that you need to do in chemistry, it's always a great idea to start by listing what you're given. So in all of these problems, we're going to have an initial situation, and then we're going to have a secondary situation, and so we want to list those things on the appropriate side. So to start with, we have a balloon that's filled with 35 liters of helium. So if there's 35 liters of helium, that's the volume. So that's initially, so volume equals 35 liters. In the morning when the temperature is 20 degrees Celsius, the temperature equals 20 degrees Celsius. By noon, the temperature has risen. So now we can tell that there's our new situation. So by noon, the temperature has risen. We're in a new situation going forward here. So now we have a new temperature in the second situation is 45 degrees Celsius. What is the new volume of the balloon? We want to know what's the volume going to be in the afternoon. So we've listed out what we were given, and by looking at this, we can figure out which of those laws we need to use. Is it going to be Boyle's, Charles, Gay-Lussac's? So we can see we only have volume and temperature, and as you saw at the end of our lecture on this, we can look at the combined gas law, and if one of those things is missing, in this case the thing that's not changing at all is the pressure, we can just ignore the pressure, so we can just drop that out. And that leaves us with Charles' law, volume over temperature. So our initial volume can be in liters. Our units don't matter as long as they're consistent. So if we leave our volume in liters, that means that our volume over here is going to end up in liters. The only units that must always be a certain thing is temperature, and it must always be in kelvins. It's not currently in kelvins. So to get from Celsius, we just add 273 to get to kelvins. So that would be 293 kelvins. Over here, we also have to add 273 because they both have to be in kelvins. So that would be 8 plus 11. I think that is 318 kelvins. So those we can use for temperature. So now we can go ahead and put it in. So volume initial is going to be 35. Temperature initial is going to be 293. The second volume is what we're looking for. So we're going to put an X there. You could leave it as a V. It doesn't matter. And we're going to put it over what we're given as our initial temperature, 318. So now we just need to solve for X. We need to get X by itself. So we can do that. We can do the division on the first side. So 35 divided by 293 gives us 0.119 equals X over 318. To get X by itself, we have to do the opposite of what's currently being done. So right now it's being divided. The opposite of that is multiplication. And whatever we do to one side of the equation, we must do to both sides of the equation. So that will cancel out the 318 on this side. The only thing we have left is X, or our volume, that we want to know. We're going to multiply by 318 on the other side, and we get 37.9. We'll just take another 986. So that's going to be our volume. It's going to be in liters because the units have to be the same. We want to go with significant figures here. So there's 3 here, there's 4 in this measurement, and there's 4 in this measurement. That means our answer can only have 3. So we can keep the 3, the 7, and the 9, but the 9's got to go up because the 8 is bigger than 5. So that's going to make the 9 turn into a 10. So it's going to be 38.0 liters. So this is the basic way you're going to solve all of these problems. List what you're given, the initial situation and the secondary situation, and then go ahead and tell us what is the difference here, or go ahead and plug in the things that you have, and then eventually you will be ready to do the math and then get your answer. So this is number 1. Please don't choose number 1, but choose 5 other problems from this and go outside and draw them on your sidewalk with some sidewalk chalk and take a picture of it for me. If you have no chalk, you can go outside and just do it on a piece of paper, but get outside and get a little sunshine, even if you have to put a coat on to stay warm. Have a great day.